Good afternoon, this is Mr. Schweitzer, and this is a quick little preview into bulk crystals of ionic compounds and dissolving. Alright, so you should have this sheet already. It's a standard workbook page, or it's been given to you. Either way, we'll get you started on a couple of these, and then you should be able to finish up the rest of them on your own. Now, first off, we have a couple things here. NaCl. Write out the dissolving equation for the following and draw a picture. Include the ratio of atoms, the relative sizes, and include at least one water molecule. Okay, so first of all, the equation. NaCl. Now, first of all, I should note that this thing is ionic. I have a metal and I have a non-metal. Cation, +1, -1 anion. It was charged balance. There's a 1 here and there's a 1 here. Okay, so since it's ionic, we would have the ions break into cations and anions in solution. Occasionally we'll have AQ on here, and AQ stands for aqueous, and this just means dissolved in water. Other terms you might see below here, which we're not using at this point but will, is an L for liquid and G for gas and S for solid. Just an FYI. At this point, a couple things that you may want to note about this. It's saying include the correct ratio. So I should have 1 of the Na plus for every 1 of these guys. It breaks apart in 1-to-1 ratios. So I want them, as I dissolve the NaCl into the solution, I want them to come, I should have equal amount of cations and anions in solution. Alright, next up it says the relative size. Okay, well, if you look on the periodic table, you would note that, and this is the last chapter, find them on the periodic table. Na is located right here, and of course as it loses its electron, become isoelectric with a noble gas, it becomes isoelectric with neon, which is in the second row, and then so it has 2 energy levels. And then they have chlorine, which is located right here, which gains electron, become a full shell, which is isoelectric with argon. So this has 3 energy levels. So we would note that the sodium ion would be smaller than the chloride ion size-wise, because this guy has only 2 energy levels, this guy has 3. So size is often something that we look for in these pictures. Include 1 water molecule. Okay, now the water molecule looks like this, and you will learn more and more in this chapter that water is what's called polar, and polar has some amount of a positive charge on it and some amount of a negative charge. Now it doesn't have the entire positive, so right here we write literally +1. That's an entire positive 1 charge. This guy has a negative 1, which is an entire negative 1 charge. Water doesn't have that. Water has a we call partial negative and partial positive. I'm going to draw that thing right here. Partial negative and partial positive. This symbol here is actually the symbol, Greek symbol delta. That's like an upper and lowercase version of this symbol. So it means change in charge, but it's a small change. Essentially it means this is another name for partial charge. And we have that little symbol we use. So I might go partial negative, partial positive. And because of Coulomb's law, force equals the charge of the positive charge of the negative divided by the distance squared, the positives and negatives will attract to one another. So when I draw my picture, I'll go H2O, and it asks me to include at least one water molecule. Okay. Now I don't have to necessarily draw on this thing that this area is positive, and I wouldn't want to go just like this. I wouldn't want to put positive because that indicates a full positive charge. If you're going to write down the actual charge, make sure you include it's a partial positive, partial negative. Now, like I said, you don't have to put that on there. You could just leave it off and say, okay, and you just know this area is positive, the other oxygen area is negative. Okay, so the positive region, I'm going to put it in here just, okay, the positive region will attract negative particles. That's the chloride. So I would draw my chloride right here. Now, there's one chloride for one sodium, so I'll draw my sodium over here. And I want to draw that thing a little bit smaller. If I draw whatever number I draw of chlorides, I have to draw the same number of sodiums. Okay. If you wanted to, you could do a key on the side. So, okay, this big chloride equals, X, and then the smaller sodium ion equals, square. And you could use those symbols then if it's easier to draw that way. And that's pretty much it. The next one up here is got barium nitride. So again, this guy here is formula Ba3N3 goes to Ba plus. Now, what's the charge on barium? You can look on the ion chart, or you could look on your periodic table, or you could simply uncrisscross this thing. You know that this is a minus, a plus 2. The plus is always the first, and that 3 here is coming from the nitrogen, which is a minus 3 nitride. So plus the nitrogen minus 3, and of course there's 3 of my bariums, and there are 2 of my nitrogens. I'll let you continue that one on your own, and then the last one I'm going to just finish up here is, well, we have this nitrate. So that's a family. So at this point, KNO3 goes to potassium plus a nitrate NO3 minus. Now, you could simply draw that out. We don't really know what it looks like necessarily, so you could just say NO3 negative equals, circle, and K plus equals square. Note that because this guy does have many atoms there, maybe we want to draw our symbol a little bit larger so that this is going to be a bigger piece. The back side just has some varying questions. Now this one, note it's a covalent substance, so there's a catch with that one, so think about that a little bit. How covalent compounds, unlike ionic compounds, do not dissociate, they don't break apart, so I will leave that one for you to think about. We have some symbols here looking for the difference between bulk crystals and molecules. And then as we come down, again creating more pictures of molecules and bulk crystals, being able to draw things out. And that is all we have for introduction to this page. You'll want to finish these up on your own.